Okay, so we go with the section 1, which is going to be, I think it's a 1.1. I check it again and let you know this is it. So we are going to talk about the graph of equation. Okay, graphs of equations. Okay, graph of equations. So this is going to be some property of these graphs. We know that an equations, of course, in 2 variables. So what we're going to do is just talk about the equation. You know that the equation is going to be a statement that gives you the equality of 2 algebraic expressions. Okay, so this is going to be, just remind you the definition of an equation. Recall that. Recall that an equation in 2 variables. We are not going to use the notion of the function so far. We talk about it later. So recall that an equation in 2 variables, okay, variables x and y is the equality of 2 algebraic expressions. Okay, 2 algebraic expression in x and y. Just a statement to give you the equation of these together. Okay, so the example, the following are going to be, this is it, the following are equations. Okay, equations in 2 variables. Okay, it's going to be just algebraic expression in x and y. So the first one, for example, is like 5x minus 3y equal to the 7. This is an equation in 2 variables. Okay, the first one. And the second one is y equal to the x squared plus 1. Again, it's an equation in 2 variables. Okay, and the next one is going to be something like x equal to the y cubed minus 1. Again, it's an equation in, okay, in two variables. You can have a various format. You may have this one. This is going to be, again, equation in two variables, not function, remember, not function. I read another one. It's x squared plus y squared equal to the 25. This is equation in 2 variables. Okay, you are familiar with some of them. You know that this is the equation of a line. This is going to be a kind of the parabola, but no names for the time being. Okay, so these are going to be the equation of in 2 variables. If you want to talk about the graph of an equation, the graph of an equation is going to be, okay, so what is going to be graph of an equation? Again, we avoid the notion of the function because we don't know it. Graph of an equation is a collection of points. It's going to be a collection of points that satisfy the equations. Okay, so the collection of points x comma y. We assume that we are familiar with the x, y coordinate, of course. Okay, the collection of points x and y that satisfying satisfying the given equation, okay, is called the graph of the equation. The graph of the equation. Okay, an equation in two variables, you have the x and the y. X and the y are going to be points. If you have this collection of points, you put them together, and the result is going to be the graph of the equation. Okay, so the graph is going to be a collection of points. Any question? So let's graph. Again, no special instruction. We're just using the general idea to graph for the time being. It's nothing special. Later on, we have some specials, and then we talk about the special techniques. But for the time being, we just collect these points and we connect them together. We need three examples to motivate the first subjects that we are interested in. Okay, let's see what's going to be those examples. So the example would like you to sketch the graph. Okay, the graph of each equation. Give us the graph of this equation. Again, very easy one. Y equal to the x squared. You know that this is the graph of a parabola. But from our point of view at this level, we just collect some points and you put them together to get the graph. Okay, so the solution is going to be, we are going to collecting the point. This is going to be the x, okay, and this is going to be the y equal to the x squared. So collect some nice points, like you start with a 0, so that gives you 0 squared, which is 0. Okay, then you start with the 1, so that gives you 1 again. But you start with the -1, that gives you -1 squared, which is 1 again. Okay, -1 squared, which is 1. And you can continue collect more points. But this is familiar, so we can graph it right away. Okay, so this is going to be the 1. Okay, we identify the 0, 0. This is going to be the 0, 0. Then we identify the 1, 1. So this is going to be 1, 1. Okay, and we identify the -1 and 1. This is going to be -1 and 1. So we have 3 points. And we know that it's going to be curvilinear because of the x squared. If it's going to be x is a, okay, we get a straight line, a rectilinear. But this is going to be curvilinear, and we put them together, and that will give us the graph of that equation. Any question? Okay, why we are interested, okay, in this graph? You see, if you look at this one, it's like if you put a mirror on the y-axis, a mirror on the y-axis, the portion to the right and the portion to the left are mirror image of each other. You see the image of this point. If you look at the mirror, the image of this point, that gives you next point over here. The coordinate of this point is going to be 1, 1. Okay, the coordinate of this point is going to be -1, 1. So this means if you change the x into the -x, you get another point on the graph of the function. So if you go to the right and to the left and get any point, you change x to the -x, you are going to be still on the graph of the function. In a minute, we are going to call this one symmetric property, and that's what we are interested in. So we are going to say that this graph is symmetric with respect to the y-axis. This is the property that we are going to be interested in, but we are going to get to it in a minute. Any question? So that would be type 1. In future, we are going to call it y symmetric. So let's get all those examples together, then we come back and officially we introduce this version. Now what's going to be the next example? The next example is going to be x equal to the y squared. That's our next example. We want to graph this equation. So again, no extra information. Okay, we know that it's a parabola, but we would like to do it by taking some points. So this is going to be the case. This is going to be your x, and this is going to be y, if you like. Since x is equal to the y square, I start taking the value for y first. So if I put y equal to the 0, 0 squared would be 0 again. So that gives me 0, 0 again. Okay, then I pick y equal to the 1. So x would be 1. And I pick a negative 1. So that gives me 1 again. Okay, you can pick more points, but we don't need it really. Any question? Now let's graph this one to see what we are going to have this part on this time. This is it. Okay, so we have the 0, 0. So this is going to be 0, 0. So we have 1, 1 again. This is a 1 and this is 1. So this is 1, 1, 1 point. Then you have a 1 and negative 1. This is going to be 1 and negative 1. So these are going to be the point of your function. Okay, oh sorry, equation for the time being. We connect them together and that will give us the graph of the function. Okay, what's special about this one? This time, if you put the mirror on the x-axis, if you put a mirror on the x-axis, the top and the bottom are mirror image of each other. You know, you can fold them together. So in that case, in this case, we say that the graph is symmetric with respect to the x-axis. So what's the property of this? You see this is 1, 1. And this is 1 and negative 1. So in this case, this means if you go up and down, you see, if you go up and down, you are going to be on the graph of the function. You see up, down, up, down. So go up and down means you change the y into the negative y. You are going to be on the graph. In the previous one, you go to the right and the left. You go to the right and the left, and you be on the graph again. Right to the left, the mirror is on the y. Up and down, the mirror is on the x. And that gives us a symmetric property that we're going to use. Any question? That's case 2. Build one more case to officially introduce the notion of the symmetry. Okay, ready for the third one? The third one is this function, this equation, y equal to the x cubed. Again, we know that we can do it quickly, but again, we need to investigate it. So y equal to the x cubed. Again, I'm going to take some points. Okay, that's it. X, y. So starting with the x equal to the 0, y would be 0, 2. Okay, that's 0, 0. So I put x equal to 1, and that gives you y equal to the 1. It's going to be y cubed, x cubed. Then I put x equal to the negative 1. So that gives me negative 1 cubed, which is going to be a negative 1. Okay. So if you graph this part, this is going to be the case. So we have a 0, 0 again. This is a 0, 0. You have the 1, 1, and this is going to be your 1, 1. Okay, then you get negative 1 and negative 1. Negative 1 and negative 1. Now you're going to connect them together. If you connect them together, this is going to be the graph of your function. Okay, this graph is going to be symmetric with respect to the origin. You see, the mirror is at the origin. Mirror is at the origin, and these 2 points, you see, are equal distance from the origin, if you like. You see, they are going to be at the equal distance from the origin. So it's like, you get the mirror image over here first, then you come down. You see, this is it. You come down here. So what's going to be the change in the points? This point is 1, 1. And this point over here is going to be -1 and -1. So in this case, you have to, you have to change the x and the y at the same time. So you go to the right and the left. You see, this is it. This is 1. That takes you to the -1. Then you have to go up and down. You see, 1, 1 into the -1, 1. So the -x and the -y. So that's where we get the symmetric property respect to the origin. Okay, so that's a motivation for the example or the definition that I'm going to talk about it. These will help you. These graphs are easy. In future, you may have to graph a complicated equation. So if you know the symmetric property, that will help you. When you know the symmetric property, you just need to graph one portion. You see the bottom one. Then use symmetry to get the top one. Or this one, portion to the right or portion to the left. That will help us quite a lot, and we are going to use it in future. Okay, any question? So this is just a motivation. So we see something and then we are going to introduce something, okay? So we see this nice property, we are going to call it symmetric property of the graph, and officially we give you one. And this is going to be your first question on the quiz number 1 and the test number 1. We give you 3, 4 equations and we ask you to identify the symmetric property. Okay, so officially this is going to be our first definition. So what is going to be symmetry? Symmetry of graphs, if you like, or the symmetric property. And this is it. So a graph is going to be called a graph of an equation in variables x and y is said to be, okay, said to be, this is it. I'm going to get all of them in one sentence. How can we? Is said to be symmetric, the first part, part 1, symmetric with respect to the x-axis, or just x symmetric, x symmetric. Okay, remember, the mirror is on the x. If the mirror is on the x-axis, you go up and down, you are going to be in the same place. So this is going to be the case. This is it if, whenever x comma y is on the graph, then you see you go up and down. So if you go up and down, then the point would be x comma negative y is also on the graph. See, that's going to be one. It's going to be symmetric with respect to the x. The mirror is on the x. So you go up and down. You see, this is a situation that we are going to be in. See, that's it. You go up and down, up and down. You see the x, they stay the same, but this is y and this is negative y. So in the equation, if you change the y into the negative y, the equation stays the same. Okay? So in the given equations, if you change the x into the y into the negative y, so you are going to get the same equation. Okay, so it's going to be symmetric respect to the x, means mirror is on the x. If you go up and down, everything would be the same. Okay, any question? So this is going to be symmetric with respect to the x. Okay, so I just write this one in this case. In this case, the equation is unchanged, or will be unchanged. Unchanged if we're just switching y to the negative y. Okay, if you switch y into the negative y and everything is stay the same, you say, oh, this equation is, this graph is going to be symmetric respect to the x-axis. Okay, any question? That's the first part. It's very easy to identify. We'll give you a shortcut in a minute. Second one, symmetric respect to the y. I summarize it. Symmetric with respect to to the x-axis, to the y-axis, or y-symmetric. Now the mirror is on the y, so you go to the right and the left. You change x to the negative x. Okay, this is going to be the case if, whenever x comma y is on the graph, then, okay, you go to the right, to the left, then negative x comma y is also on the graph of the equation, on the graph. Okay, you have a y-symmetric, so this is going to be a situation for the y-symmetric. Say this is going to be the one. So if you go to the right, to the left, you stay the same. Okay, these are going to be the one, the same. So what we do is, this is going to be your x, and this is going to be your negative x, but the y stay the same. So this means in this case, you change the x into the k. Okay, in this case, the equation, okay, will be unchanged. Will be unchanged. Okay, when we switch the x into the negative x, or the other way around. So it's going to be very easy to identify, to check these numbers. And I'll give you a shortcut in a minute. Okay, going to the right, to the left, the mirror is on the y. So it's a y symmetric. Going up and down, the mirror is on the x. Okay, so it's going to be the case. Any question? Now the third case is origin. Okay, there are some other properties, symmetric property, but we just going with these three cases only. So the third one is symmetric. Okay, it's going to be symmetric with respect to the origin. Okay, origin or asymmetric. Or symmetric. Now, you have to go to the right first, right and left first, then you go up and down. So symmetric with respect to the origin or asymmetric, this is it. If, whenever x comma y is on the graph, is going to be on the graph, then you switch negative x comma negative y is also, okay, is also on the graph of the equation, on the graph. So go to the right, to the left, up and down, you get back to the graph again. So that's the third case that we talk about it. So we get this one. If you pick this point, you see, this is going to be your x. Then you have to go back to the other side first. Okay, this is going to be the one. This is going to be your negative x. And you go down to get the, okay, to get the second points. So this point over here is x comma y. But this point over here is a negative x, negative y. Okay, so that's why the mirror is on the, at the origin, if you like, to get these numbers. In this case, we have to switch x and the y, x to the negative x and y to the negative y. So in this case, the equation is going to be, okay, the equation will be unchanged. Unchanged when x is replaced by negative x and y would be replaced by negative y. So that gives you a symmetric property with respect to the origin. These are going to be three popular ones that we use in this course. You can have symmetric with respect to the other, okay, some special lines if you like, but not in this course. You are not going to have a trigonometric function, the sine, cosine, okay, tangent, secant. If you see it in the next course, on the three course, these properties are going to be very useful for those numbers too. But we are not going to use it. Okay, so your job, we give you an equation and we ask you to determine what type of symmetric property you are going to have. Now, how are we going to check? You see, in order to check it, it's a very quick way to do it for this course. You look at the powers of the x and the y. If the powers of the x, the variable x, are all even in the given equation, all even, this means if you change x into the negative x, everything would stay the same because of the even powers. So in that case, your equation is symmetric with respect to the y-axis. If the powers of the y are going to be even, you change the y into the negative y because you are sure that the even power would take care of those negative y. If it's not going to be these two cases, you have to check the third one, okay, to give us the reason. So you must look for the even power. I'm going to give you an example, then I make a note for you to know it. Okay, that's a quick way to do it. You know, you just have a look and tell us that. You just give us the instruction and you'll be done. You don't have to check all the three cases. I've given this one on the test. You are going to have it. Some people try all the different cases. There's going to be one cases that are going to be give you. So don't waste your time. Look at the powers of the x. In this course, you are not going to have those trigonometric functions. So you have power functions only. So just check the powers of the x. Just look for the even powers only. Okay, so this is how we're going to see it. Determine officially, this is your first problem in this course. Determine, okay, the symmetric property, symmetric property of the graph of each equation, of each equation. When we say symmetric property, this is only the three symmetric property that we talk about it. X symmetric, Y symmetric, and the origin symmetric. Okay, these three only. Here you are, the first one. Y equal to 3x to the fourth plus 5x squared minus 1. You see, look at the power of the x. They're all even. So this means if you change x to the negative x, everything would be the same. Because negative x squared would be x squared. Negative x to the fourth would be x to the fourth. So changing x to the negative x means you go to the right, to the left. So this is y symmetric, and you're done. Okay, so this is, just remind you, solution. The powers of x are even. So change x to the negative x. Substitute, you have to show us y equal to the 3 times negative x to the fourth plus 5 times negative x squared minus 1. Use parentheses. So y would be negative x to the fourth would be just x to the fourth. 3x to the fourth. Negative x squared would be just x squared. Plus 5x squared minus 1. You change the x to the negative x, you arrive at the same equation. You go to the right, to the left. So the graph is, mirror is on the y. The graph is y symmetric. Y symmetric, and you're done. Any question? So you don't have to check anything else for us. You already got the symmetric property, what you want. Okay, so check for the even powers, because the even powers would take care of the negative sign. You see, the negative sign to the fourth would be making to the positive unchanged. Negative x squared making to the positive unchanged. So that's why you are going to be interested in only the even powers. Any question? So this is the way you write it down, just explain it. You get the y symmetric and you're done. That's case 1. Wait for case 2. So the case 2 is going to be case 2. Case 2, we have something like, okay, x equal to 6y to the 6 minus y squared plus 5. So look at this one. Again, you look for the even powers. The powers of the y's are all evens. So change the y into the negative y. And this is going to be x symmetric. Okay, solution, just remind you, this is just for your information. The powers. Okay, the powers of y are all even. Okay, so check. Okay, so check y into the negative y. Check if you like. Go back, substitute, x would stay the same. It's a 6 negative y to the 6 minus negative y squared plus 5. Use parentheses to confirm it. Okay, this is x. Negative to the 6 would be positive, so that gives 6 y to the 6. Over here, negative, parentheses first. Negative y squared would be, okay, negative y squared would be just positive y squared, but there is a negative here. So that make it into the negative y squared plus 5. You get to the original equation. So you go up and down. The mirror is on the x-axis. So the graph, okay, the graph is x symmetric. And you're done. Any question? Out of this section, we don't do anything. We just have a look and we say, oh, it's symmetric. Okay, but now, you have to prove it for us. You have to confirm it. So that's why we need you to just operate, to see it. Any question? So what's going to be the third case? The third case is if you don't have these nice even powers for all of them. You have a combination of these even powers, or you may not have it. Okay? So how about this one? Y equal to, okay, y equal to the 2x cubed, okay, minus 7x. Look at this one. You don't have all even powers for x or all even power for y. So we are not going to check the case 1 and case 2. It's not x symmetric. It's not y symmetric. You don't have to check it. You know it. Since they ask for the symmetric property, so the third option is the only one that you have to test. Okay, the first option and the second option is that. Okay, so it's not symmetric respect to the x, and it's not symmetric respect to the y. We can see it. So we check the third one. The possibility is going to be the third one. Okay, so the solution is going to be, so you can write it down, but you don't need it. You just check the third part. So the third part is type is going to be, you check. This time you change the x into the negative x. At the same time, you change the y into the negative y. This is the only possibilities that you have to test it, okay? Because the first and the second are not. So substitute. So we change the y into the negative y is equal to, must use parentheses, remember. It's going to be 2 times a negative x cubed. Okay, minus 7 times x. 7 times a negative x. Okay, use the parentheses. Now simplify. So that give a negative y equal to negative x cubed would be negative x cubed. Negative positive would be, I write it down in twice so that you know it, what's happened. That's the one. Negative, negative, positive, that give you 7x. So now you are going to have a negative y. Okay, the negative y equal to the negative 2x cubed plus the 7x. But remember, you are looking for y. Since you're looking for y, you have to solve for y. To solve for y, you multiply by a negative 1. Okay, you have to solve for y. So we can multiply by a negative y, negative 1 if you like. So that gives you y equal to 2x cubed minus 7x. You get the original equation. Okay, so we change the x into the negative x. We change the x into the negative x. We arrive at the original equation. So the graph is symmetric respect to the origin. So the graph is going to be asymmetric. Any question? So use these property quickly to save some times. You don't have to on the test to show that it's not symmetric respect to the x, respect to the y. We know that because we don't see any even powers. Okay? You don't see even power, so go for it. Check the third one. If you get the third one, you're done. Otherwise, it's not going to be symmetric at all. Any question? So these are going to be just 3 straightforward one. Any question? So what is going to be other possibilities? And what we are going to do when we get to those other possibilities, this is one of them. It's not the case that each equation, even if it's given to you, each equation would have symmetric property, okay? Sometimes you may not get it. So don't be surprised. And this is one of them. You see y equal to, suppose we have a y equal to the, let's say, x fifth plus 1. We want to check if this equation would represent a graph, a symmetric graph. Again, you check to check the possibilities. There is no even power for the x, so it's not symmetric with respect to the y. There is no even power for the y, so it's not symmetric to the x. So the only possibility is going to be origin symmetric. So we may check to see if it's going to be origin symmetric, okay? So again, you don't have to check all the other two. We know it by the looking at the power, okay? So the solution is going to be, we are going to checking the third case, the most possible one, if you like. Y goes to the negative y. Okay, we change the y into the negative y. This is it. We change the x to the negative x, but make sure you use parentheses, negative x to the fifth plus 1. Okay, simplify it. So that gives a negative y equal to the negative x to the fifth is a negative x to the fifth plus 5. Okay, so you want to solve for y, so you multiply by negative 1. Okay, if you multiply both sides by negative 1, or solve for y if you like, so that give me y. And that would be x to the fifth. And that positive 1 would be negative 1. You see, we didn't get the original one. We didn't get the original one, so this means this graph is not, okay, symmetric. Okay, so the conclusion is going to be the graph of this equation, okay, the graph is not symmetric. Of course, it's not symmetric with respect to the what we know. X symmetric, Y symmetric, or just the origin symmetric that we talk about it. Okay, any question? So be careful. You may get the possibility that the graph is going to be non-symmetric. So it's going to be non-symmetric, and we are going to check it. Any question? You have a couple of tricky one in your book, in your assignment. So I give you one of them. Okay, that's the number 4. So this is one of them. This is, yeah, this 4. That is the number 4. Number 5. Okay, in number 5, it's something similar to this problem, which is very popular. Okay, this is it. They give you something like a 5x cubed on the top, and they give you something like x to the 4th plus 1 over here. And they ask you what type of symmetric property they're going to have for this graph. Again, you check the power quickly to identify whether you are going to test the case 1 or 2. You see the power of you have the mixed powers. Power of the x, we get the x cubed over here, and we get x to the 4th. So we don't have all even powers. So you are not going to change x to the negative x. It's not going to be good for you. And the power of the y is 1. So it's no good to check the y to the negative 1. So the case 1 and the case 2, both of them are disappear. Okay, so that gives you the third case only. The third case, origin symmetric. Okay, so this is how we're going to check solution. So we check to see if it is going to be origin symmetric. X goes to negative x, and y goes to negative y at the same time. Okay, replace the y with negative y, that gives us a negative y. Okay, it's going to be equal to the 5. You change the x into the negative x, so that gives negative x to the 3rd. Okay, negative x to the 3rd. And then the denominator, we change the x into negative x, that gives us a negative x to the 4th plus 1. Okay, any question? simplify it nicely to see if you can get back to the original equation. So let's see what we can do. This is going to be a negative y equal to, that's a negative x cubed, so that give you 5 times negative x cubed. Over here, negative x to the fourth would be positive, so that give x to the fourth plus 1. Okay, so on the top, you're going to have a negative 5x cubed over x to the fourth plus 1. So this is like a negative y equal to, this is a sign of the fraction. So you can rewrite this one as a negative 5x cubed over x to the fourth plus 1. Any question? Because the bottom one is positive, x to the fourth plus 1 is always positive. So that's why we are not going to worry about it. So that sign on the top is going to be the sign of y. Now we have to solve for y. To solve for y, multiply both sides by negative 1 again. You see, if you multiply it by, times it by negative 1, so negative negative would be positive, and the negative negative would be positive. So that gives you 5x cubed plus x to the fourth plus 1, which is the original. Okay, this is it. That take you back to the original function. So this means this, the graph is symmetry, is all symmetric. Okay, the graph is going to be all symmetric. Symmetric with respect to the origin only. That's it. Any question? So a nice property and easy to check. And again, you just follow this instruction that make it easy for you, okay, to understand it, and you get these numbers, you know, numbers quickly, okay, to get the graph. I'll just give you this one from your book. You see, it's a nice one. You see, this is the one they give you. Any suggestion? Which one are we going to check? What type of symmetric property do you think this must be have or must have? Which case you go for it? The first, the second, or the third?
The third.
Very good, the third. Because you don't have even power for the x or the y. So the only possibility is the third. So check the x into the negative x and the y to the negative y to see if you stay the same. Okay, solution. You check x to the negative x and the y to the negative y. But you must use parentheses. You see, that's the point. It's a negative x times a negative y. You want it to be equal to 1. That's it. Negative negative would be positive. So that gives x times y equal to the 1. So it's all symmetric. Okay, this is the way you have to write down this special one. So we change the x. All the others, you know, I have to multiply negative 1 to get it, but not this one. Negative x times negative y, negative negative would be positive. So it's going to be, the graph is all symmetric. It's going to be all symmetric. Any question? So in short, if the power of the x, all of them are even, the graph is y symmetric right away, because you change the x into the negative x. If the powers of the y are all even, it's x symmetric, because you go up and down, or you change the y into the negative y. Otherwise, we don't know. We have to test it. We test if you have a mixed powers, test x to the negative x or y to the negative y. If anything stays the same, and that's it, you got it. This equation is going to be all symmetric. Otherwise, it is not. Any question? So that was our first problem. I should give a break now. It's 8:35. I give it 10 minutes. I mean, 10 minutes. We are not done with this section. This section is very dense. there is a very nice symmetric graph that we are going to investigate. That nice symmetric graph is a circle. So we are going to see what is the equation of a circle and get those information. We give you 2 problems on that one on your first quiz. So you get 3 problems for your first quiz from this section really. It's very important one. Okay, 10 minutes, I'll come back and we try to give you introduction of the circles to see how far we can go to see if we can finish these sections. And you have quite a lot of numbers, to check for your assignment. Okay, see you in 10 minutes. Okay, we are going to continue. Any question? So that's a symmetric property of the graph. That's going to be very useful when things getting complicated, okay, for future. But this is an excuse to introduce the most like symmetric graph that we are going to be interested in. Okay, it's going to be a circle. So we're going to give you the introduction of a circle. We are still in the same section, 2.1. It's very dense section. So we continue with the definition of a circle. Okay, this is it, circles. Uh, so what's going to be definition of a circle? You know that a circle, let me just remind you something that we needed for one problem. Just make sure you remember it. If 2 points are given to you, are going to find the distance between 2 points. Okay, let's recall this one first. Okay, recall that if 2 points are given to you, you see if, let's say, A is equal to x1 comma y1 and B is equal to the x2 comma y2, okay, are given points, are given points, then the distance, okay, then the distance between, okay, between A and B, you know that is defined by, we call it the distance formula. Okay, the distance formula, you know, it's a Pythagorean identity in a special case. It's going to be the square root of the difference between the x values, x1 minus x2 squared plus, okay, plus y1 minus y2 squared. Okay, the distance between 2 points. This is it. Okay, so we have the 2 points, point A and the point B, and this is going to be a distance between these two. Okay, that's a distance formula that we needed. Any question? And we need another point, another formula, and that's a midpoint formula. Okay, so also if M is the midpoint, is the midpoint, okay, midpoint on the, or of the line, okay, segment between A and B. Okay, so that's going to be the one. So we have the A, we have the B, and this is when we write in the middle. Okay, that's a middle point. We are interested in the coordinate of this point. Okay, so if this is going to be the case, then the x coordinate of the M, we call it xm, is equal to x1 plus x2 over 2. Okay, and y coordinate of the M is equal to y1 plus y2 over 2. Okay, that's the one we call it midpoint formula. Okay, the midpoint formula in algebra. Okay, so basically, if you like, the coordinate of the M is going to be, the x coordinate is x1 plus x2 over 2, and the y1 plus y2 over 2 are going to be the the y coordinates. So remember, in the distance formula it's x1 minus x2 squared, but in the midpoint it's just the average of those values. You're going to do this formula 3 times in this book, and twice is going to be in this section. We just want to make sure you remember it. So that's a midpoint formula, and the other one is going to be the distance formula. Okay, any question? Now we can get back to the definition of a circle. Now we have these two ideas, okay? So what's going to be a definition of a circle? Okay, are you ready? Give a definition of a circle. You know that a circle is a collection of points that are a fixed distance from a fixed point. That fixed point is called the center. That fixed number is called the radius. Okay, so a circle is the set, the collection of points. Let's say x, comma, y that are okay, a fixed, okay, that are going to be a fixed. What's that? A circle is going to be a collection of points that are at a fixed distance, at a fixed distance, or from a fixed point. Okay, a fixed point, C if you like. This fixed point, I'm going to denote the coordinate of this point, h comma k. That fixed distance r is the radius. That fixed number c is the center. You see that's going to be the case. I have a fixed point inside. This fixed point is c. I have a fixed distance. This is my fixed distance. And this point is the point x, comma, y. This fixed distance is r. It doesn't matter. You can pick any point you like. All the time, this is going to be a situation that we are going to have. Okay, are you done with this page? So we are going to get the r to be the radius. Okay, r is the radius, and c is the center of the circle. Okay, of the circle. I write it down again over here so I can have it. So this is it. So I have a point here. The point is x, comma, y. And I have a point here, h, comma, k. And distance in between is going to be r. So by the distance formula, by the distance formula, You see, this r is going to be a distance between these two. Okay, so okay, yes, so that's going to be the case. Yes, we can take a picture if you like. So this is going to be the case. By the distance formula, r is equal to, see, the square root of the distance between the x numbers, x minus h all squared plus y minus k squared. You see, that's a d that we talk about it. The square root of difference between the x numbers and the y numbers. So if you square it, I just want to prove it really. That's it. You have to memorize it. So x minus h all squared plus y minus k all squared is equal to the r squared. It's the one that you have to memorize. Okay? This is going to be the equation of a circle. Okay, so this is going to be, we call it the standard equation of a circle with centered c equal to the h comma k and the radius r. So I just proved it for you, just you can memorize the equation. That would be enough. That would be fine. It's nice to know how we get originally the equation of a circle, okay, to get these numbers. Okay, so this is the equation of a circle. We call it standard. So if this equation would be given to you, you should be identify that this is a circle. Whatever you have in, see, it's like x minus h equal to the 0. That give x equal to the h, y equal to the k. Then h and k is the center. You have to identify the center for us. Opposite sign, you see it's a negative h, you get the h here. Negative k, you get the k here. Whatever number over here is r squared, you take the square root, that gives you the r. R is a positive number, it's a radius. So you're not going to put a positive negative for us. Okay, any question? 3 problems from the circle that you have to know it for us. And we give all of them on your first quiz and on the first test. Are you ready? Problem number 1. That would be straightforward somehow. The equation of a circle would be given. We ask you for the center and the radius. Okay, find the center and the radius of each circle. Each circle. The first one. The first one is x minus 1 squared plus y plus 5 squared equal to the 9. You just compare with the formula and give us the center and the radius. Okay, are you ready? Solution. What is the center coordinates? C equal to, just compare them together. You see the opposite sign. So H is 1. C is the opposite sign, negative 5. K is negative 5. Or is like, x minus 1 equal to the 0, that give you x equal to 1. So that give you 1, comma, but make sure this is going to be a negative 5. So the center is 1 and negative 5. R squared is 9. So you take the square root, R would be 3, and we are done. Any question? So compare them together. This is like x minus 1 equal to 0, that gives x equal to 1. Y plus 5 equal to 0, y would be negative 5. Or when you compare them together, you see that's just the opposite sign. Negative h is negative 1. So h is 1. Negative k is positive 5. So k is negative 5. R squared is 9. R would be 3, and then be done. Any question? That's the one we call it case 1. Okay, ready for case 2? X squared plus y plus 1 all squared equal to 4. Any suggestion? What's the center in this case? Center. You see, this is x squared. You may think about it. I write it down so that you know it. You see, this is like x minus 0 all squared. See, plus y plus 1 all squared equal to the 4. So h is equal to the 0. I write it down for you. You see, h is 0. K, the opposite, is a negative 1. R squared is 4. So the center is 0 and negative 1. And the R is 2. Okay, so when it's x squared, we know that the k is equal to the 0. So we write this is going to be 0 and negative 1. 0 and negative 1. Okay, 0 and negative 1. And r squared is equal to the 4. So r would be 2, and then be done. Any question? It's going to be the third case. The third one. Okay, the third one is the other way around. If you're given x plus 5 all squared plus y squared equal to 3. You see over here, there is no y. This y squared is like y minus 0 squared. So we know that the k is 0 this time. Okay, so if you compare, so in this case, h is equal to the negative 5, k is equal to the 0. Because you can write, the same thing that I did, I can write it down for you, so you don't have to. So this would be like y minus 0 all squared. Okay, so k is negative 5, k is 0, h is negative 5, and r squared is equal to 3. So the center is negative 5 comma 0, and the r is simply radical 3. We don't usually use the negative, decimal numbers. So r squared equal to 3, so r would be radical 3, and it's accepted. Any question? So just make sure when one of them is you see the coordinate is 0, be able to identify it for us. The case 4. The case 4 is this one, x squared plus y squared equal to the 60. Any suggestion? What's the center and the radius for this one? Any suggestion for the center?
The center is 0, 0,
Yes.
and the radius is 4.
Excellent. That's it. The center is 0, 0 because x squared plus y squared. Okay. So the solution is going to be the center is 0, 0. And the r is equal to 4. And then we're done. Okay, so these are going to be various possibility that we are going to have in order to get the equation of okay, to get this center. And okay, any question? Now, these are the type that you have in your book. There is one which is missing. It's not in your book, but we have to know it. You see, the format of the equation of a circle is you can have a complete square. You see, you have x plus 5 squared, and this is going to be y squared. So it's kind of, we have to complete a square to get it. Sometimes this equation would be given to in the format that we are not to call it a standard. Then you have to do a little bit algebra yourself to get it, okay? So I would like you to get those numbers too, okay? It's not in your book, but you have to know it. It's going to be part of the deal. Okay, so pay attention for this number 5. You don't have a similar one, but you will get it in your practice one, take home one, and you may get it on the test. We usually give you one. Okay, so pay attention to this one. This is different. This is it. You may be given x squared plus y squared, okay, minus 2x plus minus 2x plus, let's say, 6y. Okay, these are going to be the case. X squared plus y squared minus 2x plus 6y. So I try to give you something it's going to be interesting. So that give you, I think this would be do it for us. Okay, that's going to be 9, 1, 10. Yeah, that would be fine. Okay, I may change this one into the 6, doesn't matter. Look at this one. You see what's going to be the difficulty? The difficulty is that you don't have those complete square, if you like. You have to use a method that we have in algebra. We call it completing the square method. Okay, I just remind you that method, or the way we are going to do it for this one. So what we're going to do for this type of problems is you put these x and the y's together. Okay, so the solution is going to be, we put the x squared minus 2x here. Okay, that's 1. Then it's going to be plus, you put these y's together, so that gives us a y squared plus 6y. Okay, and we have the 6 over there. Now, your job is what? This must be changed into the x minus h squared. We make it into the complete square. So this is the way we did it in algebra. And we're going to do it over here. So when you have a complete square, you see this is a complete square. Look at this one. If you have something like x plus m whole squared, so that give you what? That give you x squared plus 2mx plus m squared. This is the complete square, or the square of the binomial. The difficulty for this problem is this part is given to you, see? If you solve for this part, the result would be what? The result would be x squared plus 2mx is equal to the x plus m all squared minus m squared. That is going to be the case that we have. Okay? So this is a situation we're going to have. Now, so what we have is, this is the one that we have over here, compared them together. We want to make it into this part. So let's see how we're going to do it. You see, look at this one. This is 2mx. if you divide this coefficient by 2, 2m divided by 2, that gives you m. Then you put it over here, x plus m squared, but minus m squared. You have to pay for it if you like. If you square x plus m, that gives x squared plus 2mx plus m squared. So you put the negative mx squared to cancel it out. This is the method that we use for completing a square, and we're going to do it again in this course because this method is so important. We are going to use it in this course several times and in future. Okay, just to remind you to, we are going to practice more on this one. So that's why I bring it up here so that you use it. So what we're going to do is, you come here, you see, you divide this coefficient by 2. Divided by 2, so that gives you negative 1. So your m is a negative 1. So you are going to have x minus 1 all squared minus m squared. Whatever you got over here, you square it. Minus 1 squared. Okay, so it's 2 easy steps. Divide the coefficient of x by 2, that gives you negative 1. Get your squares, x minus 1 all squared. But when you square it, we get negative 1 squared. You don't have a negative 1 squared. That's why always minus m squared. Okay, so you divide this coefficient by 2, you call it m, minus always m squared. So we do the same to the other part. You divide this coefficient by 2, that gives you 3. So you are going to have y plus 3 squared minus m squared minus 3 squared equal to the 6. Any question? It's very popular method, and I was surprised. It's not in this book, but we need it. As soon as we get to the next chapter, we are going to see this type of thing somewhere. Okay, we simplify it to get the equation of a circle. So that gives us x minus 1 squared minus 1 squared would be 1 plus y plus 3 squared minus 3 squared, which is 9, equal to the 6. Now, if you move this negative 1 and 9 to the other side, that gives x minus 1 squared plus y plus 3 squared equal to the 6 plus 9 plus 1. So you arrive at x minus 1 squared plus y plus 3 squared equal to the 16. Now this is a standard equation of your circle. Okay, so now you know that what is going to be the center. The center is, the opposite sign is 1 and the negative 3. The radius of a circle is equal to the 4, and you're done. That's the best, okay, most general example of the equation of a circle that you're going to see. And this method is very popular. There is going to be 2 sections in future that if you know this method is an advantage really to get through it. That's why we practice before we get to that part. Okay, so if you haven't done it before, the completing the square, this is going to be to remind you. And it's very easy to operate. You can use this formula and we practice again. So we divide the coefficient of x by 2, you see, negative 2x. Divide by 2, that gives a negative 1. This is m. You have to pay for it. Minus always the square of these numbers. Because you don't have it. You see, a missing square. You see, your missing square is m squared. Okay, this is the one. And for the other one, we do the same. 6 divided by 2, that gives you 3, x plus 3 all squared. But you have to pay for it, minus 3 squared, which is a 9. I know that you may have used another method. Some people, they add the square to both sides. It's the same thing. But this method is going to be much, easier, if you like. So this is going to be those three problems that I talk about it, this is the first one. I'll talk about the other two on Wednesday. We stop here. Any question? So start working on this section. Okay, you have to wait to finish this, but you have the assignments. I've already posted tentative assignment 2.1. So go back and have a look. You have some very nice ones so far. When we are done with this section 2.1, you have to bring 5 questions of this section for us. As you do it, you may pick your 5 questions and keep your solutions and wait for the quiz number 1. Then you are going to send it to me, but not now. That would be enough for tonight. Okay, any question? Yes, question? Your assignment would be collected in 2 weeks' times. So by that time, you may get, you should get your book by that time. That's going to be the one. If you don't have the book, you can. Okay, let's see by Wednesday if you can, whatever we can do. Okay, any